Well, hi, good morning. Thanks so much for joining me in my shop here. It's February 27th and it's warming up again here. It's going to be quite warm. In fact, I think the prediction for the weather here is thunderstorms later today. But it's February. Thunderstorms. February. How's that go together? So, and talking about going together, what's going on with this radio? For some reason, the B plus appears to be way low, around 40 volts, when it should be up around 100, 120. The output of the radio is low, although it seemed to be a little stronger yesterday. I did have this external antenna connected, which maybe that's why it sounded a little louder than it did in previous sessions. I have changed one tube in it. I have replaced the original 12 SQ7 with a replacement. That may have boosted it a little bit, but it's still not performing the way it should. If I remove the external antenna here, this loop antenna is getting zero reception. So why the low voltage? There's not much to the power supply, and we've kind of looked at all of it. No explanation yet. So I don't even know really how to proceed. I think I'm going to have to go like square one on the rectifier circuit and go bit by bit through it, making sure everything is the way that I would imagine it should be, or the way the schematic is kind of showing it. And maybe we'll encounter something. Perhaps a mistake was made when the radio was altered. I don't know what mistake you could make exactly. Yeah. that's my opening statement there. I'm gonna go and drink some of my coffee before we even start here. Okay, we're gonna look at the schematic in a minute, but I think we should take another look at what's been done to this radio, just to be sure about things, or as sure as I can be anyway. So, got to be original speaker frame, almost certainly original field coil. Then wires were changed here on the field coil, and I'm pretty sure under here are some connections, some connections. One possibility for a low B plus is the field coil's not right and most of the voltage is falling across the field coil, but I measured that and there was not much voltage falling on the field coil. The kind of mistake that could be made there would be, because there's a hum coil in here, and these are the leads to the hum coil right back here. Somebody could get them mixed up and hook up the hum coil in place of the field coil. And if that had happened, I imagine the voltage drop would be huge. In fact, I think there'd be serious problems pretty quick with overheating, things like that. I don't really know. But in any case, the missing voltage would then be would show up across the incorrectly done field coil, but that's not the case. So I can only conclude the field coil is fine. So we look at the output transformer, only because it's right in this area. So the output transformer is here, this part here, you can see behind the tube. And so is that the original transformer or is it not? Hard to say. You can see that there's no screw holding it here. It's just held by one screw back here, one nut and bolt rather. It's attached. It's joined right here. If this were the original, it would have been probably screwed on right here, where you can see some holes in the frame here for it. They look about right, but then all these are going to look very similar. Output transformers are going to look very similar. But if it was the one from here, then why wouldn't he just move it down? Why cut and then reconnect these wires? So this is probably from another radio. Probably. If you look at the speaker that's been put on here, there appears to be two holes right here. What are they for? I don't know. Holding a transformer up here? Doesn't look like it to me. It just doesn't look right. Probably this came from a radio where the output transformer is somewhere else, or this came from a transistor radio, in fact. I don't know how old that is. Don't know when this was done. I mean, there is output coming out of the speaker, and although the volume is low, the sound is pretty much okay, so all this is kind of working. That's the weird part too, is that the 40 volt B plus and the radio is operating. So there's not much to the circuit here, and you're starting with 120 volts AC. The peak voltage there is actually 169 volts. So if you were able to recover all that in the power supply, you would end up with like a 160 volt power supply, not a 40 volt power supply. So typically you don't recover all of it, so you're somewhere in the range of 120, 130 volts B plus in these radios, not 40. So that being the case, you take, that's 90 volts we can't account for. Where's the 90 volts? I don't know, I'm waiting for an answer. I'm not getting an answer. Where have the 90 volts gone? So we'll look at the schematic now. And there's just not, just not that much to see, in fact. Okay, afraid I made a little video mistake there, and I thought the schematic was on your screen when it wasn't, so I have to repeat what I was talking about with regards to the schematic. So let's start with this strange anomaly here. You see the pilot light shown here, and one lead is connected to one terminal of the heater, which is correct, and the other lead is connected to an unused terminal on the tube, and the tap terminal, this one here, nothing's connected to it. What did they do here? So I mean, this is either just a simple error on the schematic, and this line should really come to this terminal, or this is the way it is for some reason. There would be a wire coming from here going somewhere, and the only place it can really go is right to here. So I don't know what they're doing here on the schematic. Is this in any way, and the light does glow, is this in any way related to the 90 volt, the missing 90 volt problem? No. How do you miss out on 90 volts here? It's got to be somewhere. So if we follow the leads coming out of the tube, the cathode lead, yeah, there's nothing here. There's no resistor here. There's no resistor on the schematic. Is there one in the radio? This connection is made to the primary of the output transformer. So the output transformer is implicated if something were done inappropriately here. You could be dropping all the voltage on this transformer, which would get pretty darn hot pretty quick, I would think. And what mistake would that be? That you could still have the speaker operating. I don't know. What about this capacitor? What if this guy shorts out? He shorts out. Well, if this were shorted, you'd have a short across here. You wouldn't hear anything coming out of the speaker. If it's bad, maybe it could draw everything down. Maybe it could draw everything down. Can it? Well, what kind of, like it's between, B plus and B plus. So even if this is shorted, it's a plate and screen then would be shorted. Can't really see how that. Well, yeah, you wouldn't hear anything coming out of the speaker. I don't think. Well, I don't know. I don't think this could be the cause. Some kind of wiring error. Some kind of wiring error made in this area with these things, which have been wired up by somebody else. Output transformer installed backwards. That's interesting. Well, how's it going to get you 90 volts? That's not going to get you 90 volts. on this line I am measuring 40 volts. It really implicates this. But I check the resistors here. The switch itself. What if the voltage is dropping? Well, then the AC voltage would be dropping, and the tubes wouldn't heat up properly at all. And a short in this capacitor would slow the generators at Niagara Falls. But no. Jeepers, I guess I have no explanation for how this can be. Some kind of wiring error has occurred. What if this incorrect light arrangement here has led to a subsequent error, and somebody is, like, for instance, got this right in line? Isn't that the case with some of these bulbs? That they have a way of running the B plus through them too? I don't know about that. There's a lot of things said about these pilot light bulbs which I don't think are particularly true. Like they're protecting the filaments and all that kind of stuff. I don't think so. Sheepers. Where do you go with this? Make measurements right at the tube base. Looking for the full V plus right at the tube base itself. And examine what's going on here with this wiring from the pilot light. What did they do with it? Let's take a look. Yeah, this is really quite a puzzle. So we can see the pilot light has got two kind of brown and black, brownish and blackish wire going. They're all going in the same hole. All these wires. And it's a grommeted hole. Here. I want to follow the wiring around the rectifier tube up here. Then what I'm going to do, I'm going to stop and get the lighting all set up, so get everything set up so it's nice and clear to see. So I really must warn you, this is probably going to get very tedious to watch as a video, but nevertheless, here we go. So I think the first thing I'm going to do is just look at the pilot light bulb wiring in here. Let me give you a bit of a poor man's 3D view of things. Now I'm going to wiggle the light bulb wires up above, and I think I know which ones you can see which ones they are. So they're coming up through the hole right here. These two guys. Okay, where are they going from there? Let the tedium begin. I'll fix the focus here. Okay, well, some of those wires belong to the light. It's which ones? It's this one and this one, these two. Like, see, they're going to two different pins on the tube. Now one pin is here, and the other one is right next to it. And then you can see the spare one is spare over here. It's just hanging in the open. So they've wired it the way they should have, and the schematic is showing something. I can only guess. It's just a simple error on the schematic. So that solves the light bulb. The light bulb is across the portion of the heater that's designed for it. Okay, well, what's next on the agenda here? What's next on the agenda? Trying to trace the output wires, the output transformer wires. Oh boy. So now the original wires come from down here and go through to the top where they're jointed or spliced to the wires, the two wires that come from the output transformer. So the original wires are coming from down here. I just cut them up above. Let me pull this tube out again here. And if I can wiggle one or two of those, oh boy, it's really a looking at it. I know this is not too good for you to see, but I think it's this one coming up to here. It's a very busy terminal. Everybody's hooked up to it. The positive of the capacitor, I think this is the positive. No, yeah, this is the positive, comes over. This is the positive from here too, is tied here. So we have one wire from the output transformer coming up and connecting basically to the positive terminal of the power supply. That sounds right to me. And then the current flows through the output transformer primary, and then it's a black wire that comes in here. Whoosh. Oh my gosh, how are you ever going to figure that out and see it? So I'm wiggling the black wire, but you don't even see a black wire. Can you confuse these with the... No, that's clearly the light bulb wires there. So where's the other black wire? That's it? No, it can't be. I need even more light. This doesn't add much to the deal. Okay, so there's a black wire, barely visible. That's probably it. Where the heck is that going? Oh, it's going underneath all this stuff here. There's no way I'm going to be able to get a look at it. Okay, so we can't really complete the investigation. Trying to find out where the primary wires go on the output transformer. One of them appears to go to the right place, and the other one I can't see, so we'll just assume that that's going to the right place also. The radio does work. It does make sound, so how wrong could it be anyway? Wired backwards. If you put an output transformer backwards, what would happen? It's basically a step-down transformer stepping down to the speaker. See, the other way around, it'd be a step-up transformer to the speaker. You know, I don't really know what would happen because the efficiency of the whole thing would break down too. So I don't know really what would happen. I think the result would be so crappy that it wouldn't be sustained. You couldn't use it. You couldn't use the radio like that. That's what I think. The result we're getting with the radio is good enough to say, no, the output transformer can't be backwards. How would that affect the voltage anyway? I'm kind of off track on the voltage. Okay, other wiring around the around that tube. You know, I'm going to put it up on the screen here so we can see it while I'm working. Okay, now we're trying to sort of verify that the wiring here and into here is correct. So they've shown the key on the tube right here, and this is pin 1 going to ground. That all makes sense, and pin 2, this matches my tube book. So these are in order. So we should be able to follow this order and compare. So we should start by locating the key on the tube. And I don't know, should I use the other camera for this? Yeah, maybe I'll just move this one closer because I can't get too close anyway. It'll be interfering with my own ability to see in here. Okay, there we go. Nicely lit. The key. Where's the key? Key is right here. So this is pin 8 I'm pointing at. Pin 1 would be here. Pin 1 should be grounded. Pin 1 is not connected. You know what? It's a glass. Oh, this is a rectifier tube. So pin 1's not necessarily connected. Well, why not look at the schematic, Jim, and see what it shows? Which shows it grounded, but it's not. Okay, I don't think that's an issue at all. Next pin has wire coming over to the switch. So we're looking now at this pin has a wire coming over to the switch. How does that work? The pin 2 is one leg of the heater, and it's got other wires coming to it. They haven't bothered showing the heater wires because it's up here. So you would find pin 2, this would be pin 2, and coming from the switch. There we are. Okay. Pin 2, wire going to the switch. Okay, pin 3 is the tap, and the light is attached to it. So pin 4 is empty. Pin 5 should have the resistors on it. Okay, pin 5. And so we'll count backwards now. So we'll count backwards. 8, 7, 6, 5. That's 5. And there's a bit of excess wire here. And it's got these resistors hooked up to it. And let me just grab that little tidbit of wire in there. It's nowhere. Yeah, it's nowhere near. Maybe this is short. No, it's nowhere near. Besides, I think that would again wouldn't explain 90 volts over to the switch. Resistors go to the switch, so resistors go to the switch. The other side's on the plate. That's exactly right. That's exactly right. Not much left here, so we go all the way around to pin number 8. 8 is this one. It has the positive side of this capacitor hooked up to it. So pin 8 has the positive side. Hey, I haven't changed that capacitor. This capacitor's shot. Maybe that's all it is. This capacitor somehow is pulling the voltage down. It would make it pretty hot pretty quick. Could it be that simple? Well, I haven't got much else to go on here, really. If it's not that, what could it be? So I think I'm on my way to replacing this guy anyway. Made in New Jersey. 40. Well, you know, really, well, I got to change this out. That's what we got to do. That's really You see, I think if this were dropping 90 volts, if it were eating 90 volts away, it would get so hot so fast, it would have been obvious right from the start. Let's cut it out. Let's cut it out. So negative lead. Right, I soldered the power wire to the negative lead here, just to make it easy. I'll leave enough lead I can test the capacitor. I separated the wire from here too. Okay, gotta remember that. Let me put a clip lead on it. Here. Oh, how much do I bet this has been the problem all along? I just didn't clue in. Whoops. Okay, let's test it with this tester first. So it thinks it's 18, not 40. 38% V loss. That doesn't sound very good, does it? 1.5K, so 150 ohms. But none of this sounds very good to me. A little hard to test these guys to see if they're leaky because they're kind of leaky from the start. Electrolytic capacitor. So we'll put another one in there. See if the full B plus shows up, and maybe that's all it is. Okay, so I've got the new capacitor installed there, and as much as I don't think this can be the cause, basically because I think the capacitor would have roasted in front of us. Oh, we better put this tube in. Somehow I think this is going to fix the problem. Problem being low B plus. Okay, we'll set this up here. And I'm going to clip lead my negative one to a negative spot. Here's a negative spot here. Negative. Okay, just go right across the capacitor like so, and we should get a reading. 40 last time. My expectation is this time it's going to be 120. Are we ready? Okay, so if that's the case, that means the first time this radio's experienced that kind of voltage through its high voltage circuits. So something else may happen in short order. Let's find out. Okay, oh, got a plug here. Plug it in here. Get this out of here. Okay, here we go. Switches on, volume up just a wee bit. And here we go. Watching the dim lights. The dim lights. Kind of normal behavior there. Quickly, man. What's the voltage? Nothing yet. Oh, don't like this. Here we go. Come on, keep going. No, it's going to settle in at 40 again. She's going higher. Going all the way. So it's heating up very slow because I've got it running on 97 volts. So there we are. There's the B plus coming. let's. Now I think my outdoor antenna switched. Otherwise, which is the antenna that's built into it. Well, I fixed it, but now it doesn't work. We're only at 96 volts. We really need to go higher. I hear something coming out of there. Let's check again just before we put the full Monty on it. So we're at 87. Now I'm going to give it the full voltage here. Now we're getting up where it should be. Wonderful. So it was the capacitor all the time, the whole time. The one part I kept telling myself, nah, it can't be that, can't be that, can't be that. Well, that means this guy must have been getting hot, because it has to dissipate power. And we just never noticed. Okay, that's fantastic. Now, other things could start getting hot in here. It could be other capacitors taking the heat now. And let's tune the radio somewhat. That's slipping. Okay, it's working. Okay, fantastic. We've got the power here. Well, that's a little bit surprising to me that that's what was causing the problem, for reasons I have stated a couple of times. I have to readjust my sense of reality here a little bit. Okay, so what are we left with now? Now we can get on to doing the basic restoration tasks, mostly getting rid of these wax capacitors. And again, I think I mentioned before, I want to start in the audio side of things and work my way out. And I think the first thing we want to do is look at the bias of the output tube. So that'll be the next thing to take a look at. Bias of the output tube. Coffee break time though, for me. Okay, the grid on the output tube is pin number 5. Okay, let's get this going. Pin number 5 is, here's the output tube, 1, 2, 3, 4, 5. Okay, so I can see pin 5. Looks like this, if you can see it, this capacitor is on pin 5. Okay, are we operating yet? Again, very slow warm up. Good enough for now. Let's check B plus again. I'm on the 500 volt scale over here on the meter. And so if we go on the positive here, that didn't look very good. 150 volt scale. Oh, it's because of where I'm reading to. I shouldn't have that there. This should be connected to the to a negative, like a B minus point, which would be, he says, nervously reaching in right there. Scary. Okay, there we go. Now we check it. Ooh. Very low. I wonder if it's because I'm running the set at 100 volts and the rectifier can't do its job, and that's why the output voltage is so low right now. Has that been the problem the whole time? Come on, can't be. Okay, so this is 50 volts full scale, And look, we're getting 30 volts again. Maybe maybe there never was a problem. It's just operating at a too low a voltage all the time. Okay, let's go up. Give it the full works. 150 volts, full scale. That's 50 volts. That's not doing very well. Wait a minute now. What has changed? Well, it's still going up. That's a little weird. It's taken this radio all this time to get up to 115 volts now. So it got there. Okay, I don't know what to think of that. So now we're going to take a look at the voltage on the grid of the output tube. Now I'm doing this with a 10 megohm voltmeter. It's really not enough. So as soon as I touch the grid, whatever voltage is there is going to collapse to some degree, I imagine, I expect. And I'm looking for a negative voltage, but I'm thinking it's going to be positive. So what we're going to do is I'm going to put this on 50 volts, and it should be negative, but it might be positive. I'm going to count the pins again just to be sure. I don't want to get it wrong. 1, 2, 3, 4, 5. Okay, what do we see over there? Way up, way up. So that measured 25 volts positive. Now, what I really want to do though is I want to read the voltage between the cathode and the grid. I'm going to use this kind of meter because it's totally ungrounded. I'd be a little nervous using the VTVM for that. Okay, so we're looking for some small voltage. Proper bias voltage would be somewhere in the range of 10 volts or so. Negative, 10 volts negative. So I've got to figure out the cathode. I know where the grid is. I need to know where the cathode is. 50 L6. Cathode is on 8. Cathode on pin 8. So I'm going to want to go directional antenna. I'll have to keep that in mind. Okay, so now I want to put the negative lead on the cathode, and then I'll put the red lead on the grid, and I would expect it should be what I would expect. It should be a negative voltage. I'm expecting it to be positive though. Why? It's just the way I am. So pin 8 and pin 5. Okay, and I don't want to really put my hand on the chassis here to steady up. Wow, there's a wire tail. I left a wired tail here. That's I gotta watch out for. Okay, gonna have to put. I don't want to do that. Okay, got one on. Gonna be able to see the meter. Other one. 1, 2, 3, 4, 5. Oh, for crying out loud. Minus 4.5 volts. Okay, that's surprising. I mean, it should be minus something. Let's see what the book says about what the book says. Let's see what the book says about what the book says. Did I just say that? I think I did. 50L6. So look at typical operation. And grid number 1, control grid voltage, minus 7.5 volts with a bias of, with a plate at 100. Plate's a little bit above that. So this is looking for minus 7 volts. I got minus 4. And we're feeding the radio with 115 volts, so it's getting its normal supply voltage. So maybe a touch low, but the point is it's there. It's negative. That's the main point. Now, there is a blid clocking capacitor. There is a grid blocking capacitor. Let's look at it on the schematic here. So if we look at the grid, this is very hard to make out here. But it should be coming from the plate of this. This must be the grid here. It's just about impossible to look in here and sort out what's going on. So this capacitor here has to block DC that's sitting here to run the plate of this tube. So there might be this is usually a low B plus here, 50 volts, something like that. And if this guy is leaky at all, some of that positive voltage, it's a terrible way to put it, but I'm going to put it that way. Some of the positive voltage will show up on the grid. The grid is being forced negative through something here. I'm not sure whether it's self-biasing. I doubt it. It's probably something to do with these resistors and the way the power supply was done. And I just never sorted it out. So somehow it's getting a negative force against it, and possibly a positive force against it from here. And the end result is minus 4 volts when it should be minus 7. Something of that sort. If we change this capacitor, put a new one in, there'll be no chance of leakage through here, and perhaps the grid will go more negative here, which would be helpful. It would be helpful if we can do that. So that's the capacitor to change, and it's connected plate to grid C12. And what is it on the chart? 0.05 or 0.02 C12. Oh, a very small one, 0.005. And it was 12. It's 13. No, it's 12. It's 12. Yeah. Okay, so 12 is connected to pin number 1, 2, 3, 4, pin number 5, which is the grid pin. Yeah. Okay, look at the radio and find that capacitor. Might be a good idea to shut the power off at this point too. Okay, I'm going to pull this out of here. Okay, so pin number 5 is counting here. So I'm putting the light right in front of the camera. Pin number 5. That's 5, so looking down very clearly, that's the capacitor there. It runs down and hooks up onto this other tube, just as shown in the diagram. So this guy's leaky. This is probably the one position where if the capacitor is leaky, it's bad news. So let's cut it out of there, and we're going to give it a test. And go bleed, please. 0.005. Yes, 0.005. Looking to be in rough shape. Just dirty, but the wax looks pretty good on it. So we could interpret the -4 volts instead of -7 volts as a indication that this capacitor is leaky. On the assumption that the radio designers really did want the bias to be up closer to -7. So we have kind of an indication already this is a leaky capacitor, but we don't know it. Mind you, a capacitor this age coming out of a radio like that, for one like this to show up in a like new condition, I don't think it's ever happened to me. So the idea here is we watch the magic eye here, and you see the dark pie shape area down here. When I hit the switch here, apply voltage to the capacitor. I'm going to start with 50 volts. The current flow will cause the eye to close. And when the current stops, the eye will open again. But if the capacitor is leaky, the current never stops, so the eye stays closed to some degree. And I can kind of judge a little bit on just how bad a capacitor is by what voltage it can take and keep the eye open. Here we go. Can it do 50 volts? Oh yeah. Can it do 150? Oh, this capacitor is testing really good. So at 250, it's not quite opening all the way. So as old capacitors go, this one's pretty good, but it is leaky, and it is in a very sensitive place in the radio to have a leaky capacitor. So we'll put a new 0.005, and we'll repeat the grid voltage test and see if we haven't made the grid a little more negative by doing this. Okay, so I'm going to install that capacitor, and then we'll do the test. Somewhere I'll drink some coffee in there too. Okay, I've got the new capacitor installed here. So we're ready to give this guy a go. I'm just checking. Here we go. Okay, let's first check for B+, the slow motion B+ here. Why so slow? Well, there's some heater problem in one of the tubes, and it takes a while to for the heater tube voltages to get at 55 now and going down. So it's 115 volts. The radio's plugged into 115 volts. There's a very strange behavior here. When's it going to go up? It keeps going down. Okay, it's starting to go up now. Sort of. Oh! What happened there? Connections here. This doesn't make any sense at all. 42. Going up. We're going up now. This is very unsettling. To find a problem with the tube heaters, I'd have to measure the voltage drop across each heater. And it should match the tube number. You know, if it's a 12, it's a 12 volt tube. Okay, what's it now? You can See the speaker starting to come to life. It's still very low. Really weird stuff going on. The pilot light is behaving normally, which is to say it's not fully bright. This is definitely a weird one. Now, I thought I'd solved it with the new capacitor. There's that interference that I suffer from here. That'd be more fun to go after that than to continue here. Okay, let's look once more. Where are you at now, Mr. B+? 68 and slowly going up. Okay, let's take a look at the voltage on the grid, which I'm going to put this over here, I think. Which I measured at -4 volts last time. -4 volts. Okay, again, to put the negative lead on the cathode. Number 8. And the positive lead on the grid. This might be noisy. Okay, and we'll put this lead here. Right, the capacitor is right there for me to short it out. I don't want to do that. Get your reading, man. Quickly. It's less negative. It's supposed to be more negative, not less. Of course, the supply voltage may not be up yet. Let's look for that. Where are we at? .72 volts. Still climbing slowly. Oh, thanks. Yeah. Yeah, I think I'm going to have to test each tube voltage drop across the heater and see where we're at. This is the kind of thing I've very, very seldom done. Really, if ever. On the output tube, it's 2 and 7. So we switch this to AC. Where's the AC? AC 60 volts. So we should expect to find 50 volts on a 50L6 between pins 2 and 7. 2 and 7. 2 and 7. Volts AC. 50 volts. Okay, that's pretty close. And on any of the other tubes, and I don't know their heater, the heater's offhand. 35 volts across the heater of the rectifier tube. Let's check that one too. The rectifier tube is a 35Z5. 35Z5. Heaters are 2 and 7 again. Is this a good idea to do this? 2 and 7? Because, no, there's a cathode in here. So yeah, there's a cathode in this tube. So 2 and 7 on the rectifier should give us 35 volts. 2 and 7. 2 and 7. 2 and 7. Okay, there we are. That's okay. That's 2. Oh boy, 7's a little hard to get at. Whew, 7. Sparks are going to fly here. Oh, I got my other hand in there now. I should have had it at the ready. 2. Oh, this is scary stuff. Maybe I go on to 2. And then go on to 7. Somebody read the meter to me. 4 volts. 4 volts. It's supposed to be 35. How do you get that? How do you get that with the light going? How can the light go? Maybe I measured across the. I measured across the whole thing, didn't I? Sure I did. Sure I did. 30. So we're on to something here. 35. This radio's full of. Where's the voltage? Where's the voltage? 5. So 2 and 7, unless I did 3 and 7 by accident, which I could have done. So check 2 and 7 very carefully, and look for 35 big volts on there. 35 big volts. Okay, looking very carefully now. 2, 8, 7, 6, 5, 4, 3, 2. Now that's the one I had it on. 2. Don't touch the chassis. I should put flash glasses on to do this. 2. Oh my God, how am I going to get my other hand in there now? I can't. Tension is good in videos. People like tension. Like watching other people. Oh yeah, don't do that. Right there. 4 volts. Open heater. Partially open heater. So you can see the heater in these tubes, for crying out loud. The open heater in one tube means all tubes go dead. A partially open heater, that doesn't even make sense. Don't even know what I'm talking about. I'm talking about the tapped heater in the rectifier tube. Let us see. Oh, look at it. It's just beaming along just fine. I'm going crazy. There's the light. That's fine. Is there something wrong with this radio anyway? I mean, string not doing very well. And you can see the damage to the speaker a little better now. It's actually a tear all the way through it here. Well, okay. It's just driving me crazy. It's driving me lunatic. Okay, I'm going to turn this off. And you know, I just realized I've never really thought about this too much. My little control panel here, the switches are metal. These are metal covers. They're not, so when I touch the switch, I'm grounding myself into this guy here. Never thought about that. Now, mostly I don't have to worry much about being grounded because the work itself is in an isolation. It's hooked up to an isolation transformer. Not only this one, but another one, oddly enough. And so there's no reference to ground. You can't drive current from a project here into the earth that I'm not really standing on the earth, but you know what I mean. So so that's how I'm maintaining my safety in the shop here just a little bit. I don't want to talk too much about that. I don't want to be the one guiding people on protecting themselves in these situations. Okay, I think I'm done for today. Oh, you know, I never did check the grid voltage. Well, because we're on to another issue. What's going on with these tube heater voltages and the very strange slow heat up? You know, if you had something that was intermittent, maybe you got it open for 50 volts, and when it closes, you get the full. I don't know. I know. Stop thinking. Okay, yeah. Tomorrow we will look at the tube heater voltages carefully and see if we can find something out there, because there are a lot of weird behaviors with this radio. Thanks for watching, and see you tomorrow.